for both hazardous material and worker exposure assessments. These are the things that you can't see oftentimes and you can't feel. These oftentimes can create acute symptoms of exposure, but more than likely often incorporate a chronic risk, which could be anywhere from 10 to 40 years down the road. And this is something that I hold very dear to my heart, and looking forward to hearing the presentation today, because I feel that this is something as an industry we could do better at and continue to improve on. With that being said, I'd like to bring to you our guest speaker, Umer Khan, Director of Industrial Hygiene Services at the infamous NVL Laboratories. Umer, thank you so much for joining us today, taking time to share valuable information with our group. I'm going to turn the floor over to you. Thank you.
Thanks, Rhett. I'm going to quickly share my screen. All right, hopefully everyone can see the screen.
Yes.
Perfect. Well, good morning, all. I'm Umer, like Rhett said, with NVL Labs. Today, myself and I have with me Raymond, who is our manager, and Russell, who is our supervisor. We'll be giving an overview of hazardous materials surveys and worker exposure monitoring. So today's agenda, I'll briefly walk through why renovation and demolition are at high risks, what hazardous materials assessments are, what exposure assessments are, and how federal and Washington state regulations drive the requirements. So why renovation and demolition is at high risk? These activities disturb material that may have been safely contained for decades. Once disturbed, they can release dust, fibers, fumes, and noise. And when work is often done right or in tight schedules, it increases chances of mistakes. And a lot of things are overlooked, which can create a hazardous workspace, not just for the workers, but for whoever's occupying it after. So there we go. So typical hazards include asbestos, lead, PCBs, mercury, methane in subslab conditions, and silica. Many of these are invisible during normal occupancy, but become serious once work begins. So, what is a hazardous materials assessment? A hazardous materials assessment is a pre-work evaluation of building materials. It's required before renovation or demolition and provides the information needed for permitting, abatement, planning, and worker protection. I'm going to hand this off to Raymond now.
Hello, everyone. My name is Raymond Pacheco, and I'm a senior industrial hygienist and manager at NVL Laboratories. So in this section, I'll give a quick review of the regulations that apply to hazardous materials we commonly find in buildings. These rules guide how we identify hazardous materials, control exposure, and make sure hazardous materials are handled and disposed of properly. At the federal level, we have the EPA's National Emission Standards for Hazardous Air Pollutants, otherwise known as NESHAP. NESHAP regulates asbestos during renovation, demolition, and maintenance work. NESHAP requires building owners and contractors to identify asbestos before it's disturbed, follow specific work practices to limit fiber release, and notify regulatory agencies ahead of certain projects. The goal is to protect workers, the public, and the environment from asbestos exposure. Next, we have the Asbestos Hazard Emergency Response Act, otherwise known as AHERA, which sets standards for inspecting and managing asbestos, especially in schools and other institutional buildings. AHERA outlines how inspections and sampling should be done, how materials are classified, such as friable versus non-friable, and what response actions are required. We also have the Toxic Substance Control Act, otherwise known as TSCA, which covers the use, handling, and disposal of toxic substances, including PCBs. Under TSCA, materials that may contain PCBs like electrical equipment, caulking, paint, and fluorescent light ballasts have to be properly identified, labeled, managed, and disposed of according to EPA requirements. TSCA also sets cleanup and reporting requirements when PCB contamination is found. On top of federal regulations, you have the Washington State rules and local clean air agency requirements, which are also important. These agencies often have requirements that are just as strict or even more stricter than federal standards, which can include additional notifications, permits, and enforcement steps, all of which need to be addressed for a project to move forward. Together, these federal, state, and local regulations form the foundation for hazardous material surveys, risk assessments, and abatement planning. Understanding and following these requirements helps keep project compliant, protect worker and occupant health, and support safe renovation, demolition, and ongoing building management. So in this section, I'll give a quick overview of the Asbestos Hazard Emergency Response Act, also known as AHERA, and its influence on hazardous material surveys. AHERA is a federal regulation enacted in 1986 and enforced by the EPA. Its primary purpose is to protect individuals from exposure to asbestos. Although the regulation was written specifically for kindergarten through 12th grade schools, the inspection and sampling protocols established have become the industry standard and are now widely applied in commercial and industrial facilities. So several key elements of AHERA contribute to the successful completion of a hazardous material survey. These include inspector training requirements, the identification of homogeneous areas, and established procedures for bulk sampling and laboratory analysis. Under AHERA, asbestos inspections must be conducted by EPA accredited inspectors. These inspectors are required to complete approved training programs and maintain their credentials throughout periodic refresher courses. This training ensures inspectors can accurately identify suspect asbestos-containing materials, understand building construction methods, safely collect samples, and properly document inspection findings. The intent is to promote consistency, accuracy, and safety for both workers and building occupants. During inspections, materials are categorized into homogeneous areas, which are defined as materials that are similar in appearance and were likely installed during the same time period. Examples include pipe insulation along comparable piping runs, floor tiles of identical size and appearance within a room, or sprayed applied fireproofing on structural steel. Grouping materials in this manner allows inspectors to collect representative samples rather than sampling every individual component while still ensuring reliable and defensible results. AHERA also establishes minimum sampling requirements based on the type of material and the size of the homogeneous area, with larger areas requiring greater number of samples. Sampling is conducted using appropriate personal protective equipment and wet methods to minimize fiber release. All samples are then tracked using proper chain of custody documentation to maintain data integrity and defensibility. Once the samples are collected, samples are analyzed by EPA or NVLAP accredited laboratories, most commonly using polarized light microscopy, PLM. The laboratory analysis determines the presence of asbestos, identifies the asbestos type, and estimates the asbestos content. Under AHERA, any material containing more than 1% asbestos is classified as an asbestos-containing material. Overall, AHERA provides a clear and defensible framework for identifying asbestos, protecting building occupants, and supporting safe and compliant building management practices. Washington State asbestos survey requirements. So in this section, I'll outline the asbestos survey requirements applicable to construction projects within Washington State. So under Washington State law, an asbestos survey is required prior to the commencement of any demolition or renovation activities when building materials may be disturbed. These requirements are designed to protect workers, building occupants, and the surrounding community from potential asbestos exposure. For demolition projects, Washington State mandates the completion of a comprehensive whole building asbestos survey. This survey must include all accessible areas and materials within the structure, regardless of the building's age or condition. This requirement is established under RCW 49.26 and WAC 29662077721, and is consistent with federal EPA NESHAP regulations, which also require thorough inspection prior to demolition. For renovation projects, the asbestos survey is limited to materials that will be disturbed by the defined scope of work. This type of survey is commonly referred to as a good faith asbestos inspection and must be performed by an AHERA accredited asbestos inspector in accordance with Washington State Department of Labor and Industry requirements. It is critical that the asbestos survey be completed before any disturbance of building materials occur, including demolition, renovation, maintenance, or repair activities. Survey findings must be documented in a written report and made available to contractors prior to bidding or the start of work. Failure to conduct a required asbestos survey may result in regulatory enforcement actions, including stop work orders, project delays, and financial penalties. Conducting these surveys early in the project life cycle helps ensure regulatory compliance, protects workers' health, and supports the safe and efficient execution of the construction activities. So where is asbestos commonly found? So asbestos was widely used for its fire resistance and durability and can be found in thermal system insulations, which include pipe insulation, mag piping, air cell, fiberglass with ACM wraps, boiler insulations, duct insulations, hard cast or cloth lagging on ductwork, tank insulations. This material typically is found in mechanical rooms, crawl spaces, boiler rooms, basements. You also have surfacing materials such as spray applied fireproofing, popcorn ceilings, plasters and skim coats, which are commonly found on ceilings in offices, residential structures, on walls and ceilings. You also have flooring materials such as vinyl flooring, 9x9 vinyl composite tiles, 12x12s. You have sheet flooring and linoleums, mastic and adhesives. These materials are usually found in kitchens, bathrooms, tiles, under tiles, carpets, in panels. Because many of these materials appear similar to non-asbestos materials, their presence cannot be confirmed visually and must be verified through inspections and sampling. So lead-based paint assessments. So lead-based paint is most commonly found in buildings constructed before 1978. The year when its use in residential settings was banned due to the health risks associated with lead exposure. During a lead assessment, the goal is to determine where lead is present and whether it poses a hazard. So there are two types of lead assessments that can be performed during a survey, which include a risk assessment and lead inspection. Risk assessments are a series of testing that includes painted surfaces, soil, and dust to identify if lead sources pose a health risk to occupants. Lead assessments are typically conducted prior to purchasing or moving into homes, especially if children will be occupying those spaces. Lead inspections are a surface by surface investigation, which locates and determines how much lead-based paint is present in the structure. Lead inspections are conducted to determine if remediation is required prior to renovation and demolition activities. So the inspection process typically includes pre-inspection planning, such as confirming the age of a building, looking at the scope of work and what the regulatory requirements are. Also a visual inspection, where an inspector will identify painted surfaces, note different type of substrates, identify distinct building components, and then lead testing, which is typically done on site using an X-ray fluorescence or XRF testing, which allows for inspectors to quickly scan painted surfaces and identify lead content without damaging the materials. And it also includes paint chip sampling, which includes collecting samples of paint down to the substrate and having those samples submitted to an accredited lab for analysis. So if lead paint is discovered on site and repairs or renovation or abatement work is completed, dust wipe sampling will then be performed. This step is critical. It verifies whether lead dust levels meet federal and state clearance standards, ensuring the space is safe for reoccupancy. So overall, these assessments help property and contractors understand potential sources of exposure, guide safe work practices, and protect both occupants and workers from the serious health effects of lead. So next we have polychlorinated biphenyls, also known as PCBs. So polychlorinated biphenyls, also known as PCBs, are toxic man-made chemicals often found in buildings constructed or renovated between 1950 and 1979. PCBs were used as plasticizers for flexibility and in sealants for stability. Their durability and heat resistance led to widespread application before regulatory restrictions were established. Common and often hidden sources of PCBs in buildings also often include caulk and grouting materials such as exterior and interior joints, masonry joints, and window glazing. It could be found in coatings and adhesives such as oil-based paints, floor finishes, mastics under flooring or carpets, and in electrical equipment such as ballasts and older fluorescent lighting fixtures. PCBs are classified as a probable human carcinogen and have effects on the immune, reproductive, and nervous systems. PCBs can enter the air through vapor or dust when materials deteriorate or are disturbed during renovation and demolition activities. And this is one of the reasons why it's important to include PCBs in a hazardous material survey if you're dealing with older structures. PCBs are also regulated under the Toxic Substance Control Act, also known as TSCA, specifically 40 CFR 761, which governs the identification, handling, cleanup, and disposal of PCBs. Any building materials containing PCBs must be managed in accordance with these federal standards. PCB containing materials require controlled disposal. Items with PCB concentrations at or above 50 parts per million must be transported and disposed of at TSCA-approved facilities. Proper labeling, packaging, and documentation, including manifests, are mandatory. These measures prevent environmental contamination and ensure regulatory compliance. So other hidden hazardous materials that are often found during inspections include paint and coatings, which can have lead and PCBs. Depending on where you're doing an inspection, some paints can also contain asbestos. You also have concrete and masonry, where crystalline silica can become an issue during demolition activities. Also, if you have PCBs in a structure, PCBs could contaminate concrete and other masonry materials through permeation. So it's important to have those tested as well. You also have lighting systems where PCBs are in ballast, mercury and light tubes, and lamps, and then also older sealants and caulking where PCBs are most commonly found.
Thanks, Raymond. So the deliverables from a hazardous materials assessment pretty much will provide you with a survey report, which will include photos of the sampling locations, the samples, and then maps of the footprint like you see below where samples were taken for all asbestos, lead, PCBs, or whatever you are sampling for. In addition, you'll find the laboratory results to show what was found. And then you'll also find the abatement and disposal guidelines. And this is typically all done before, it should be done before the work commences, the contractor work commences. So what is a worker exposure assessment? This is an assessment that measures what workers actually encounter while performing tasks. It uses personal or task-based air monitoring that helps confirm whether the controls in place are effective or not. And now I'm going to hand it over to Russell.
Perfect. All right. Thank you, Omar. So my name is Russell Kwame. I am on the industrial hygiene services side of our company. I'm the supervisor in that end of the company. And what our side does is we do a whole bunch of different site visits that relate to worker exposure assessments or assessments for what just general industrial hygiene hazards might be present. We do a lot of different worker exposure assessment visits that are related to things like asbestos, lead, respirable crystalline silica. And then there's a whole big list of other miscellaneous things that we'll come into contact with and we'll do exposure assessments for. So I'll run through some of the main things that you'll encounter of what you might need when you're encountering a site or a work environment where you would need an exposure assessment. So for just asbestos in general, when you have a worker that is doing a job where he's doing asbestos abatement, it's very common to have a situation where you need air samples collected, and those are going to often be performed as two categories. And these categories will, in different ways, align with a lot of different compounds you'll encounter. For asbestos, you'll have categories that collect samples that are called a time-weighted average, and that are called an excursion sample. The time-weighted average is the type of sample that you'll see. This is the most common type of sample where it's generally collected over a full day's work shift. A worker is given an air pump and they've got an air sample that's then attached to their lapel, and they're collecting a sample over a full day's work to give a result of what is their overall exposure during their tasks for the day. Then you also have the types of samples that are going to be called short-term exposure or excursion samples. And those are the types of samples that are for a very short period of time, for either a 15-minute or a half-hour period. It depends on which type of compound you're dealing with. For asbestos, it's usually known as a 30-minute excursion sample. And those are telling us what is the highest exposure that an employee might be exposed to make sure that we're not exposing them to any level that is beyond the healthful limits of that compound that's put in the Washington State Administrative Code. So here's our list. We've got our 4 different references to the WAC. I've got our 3 main sets of categories of asbestos, lead, and respirable crystalline silica. And then if you go to the 841, the 296-841, that's your reference for if you're ever dealing with a rarer compound and you need to go figure out what's is my carbon monoxide level in any sort of level that's outside of the norm, or am I dealing with acetone at a level that's outside of the norm? If you've got any strange chemical that is impacting your work site, that's going to be one of the references that you can go to that gets your permissible exposure limits set down, and that you can figure out what's going on. So next, I'll go over some of the key exposure limits and what these are talking about. So first off, I've already mentioned this, but we've got these are all different types of permissible exposure limits, each of these 3 categories. So first off, you've got an 8-hour time-weighted average. And this is a type of sample that is not necessarily collected for exactly 8 hours. It's time weighted to 8 hours. And so you'll collect a sample from a worker, and that worker will be hooked up with an air pump. He'll have done his task throughout the day. And as he's performed his task, the worker will be just having that sample run for the entire workday. And that sample is allowed to be used as a representative sample for a site when we've got all the same conditions present that other employees would be exposed to. So when we do an exposure assessment, we want to make sure that the conditions that are normalized are for the manner in which the work is performed. We want to make sure that the environmental conditions are similar, that we're not making any changes, that the nature and concentration of contaminants that are being used is the same across a sample collection, and that the scope and duration of the work is also the same. So if we have any significant changes in that set of requirements, that means that we would need a different sample, a different exposure assessment to be referenced or used in order to still have an assessment that says, yes, this worker is not being exposed above that permissible exposure limit for whatever the nature of their tasks are during the workday. So say I've got silica samples. I've got a construction worker. He's doing some sort of masonry work. Maybe he's jackhammering. Maybe he's doing something that generates silica containing dust. If we have a enclosed room with very little air ventilation and he's doing a task that generates dust, that would not be the same exposure assessment as if I then take that worker and move him outdoors and do the same thing. I've got completely different environmental conditions, so we would want different assessment levels to and a different sample to show that the conditions are not outside of those helpful limits for that. Then we've got short-term exposure limits as well. This is when you've got a job where there's based off of the engineering controls and based off of the different things you can set up, there's not really a way to get outside of the risk of there being a pretty high exposure to an airborne contaminant. Short-term exposure levels are generally, they're always going to be higher than the 8-hour time-weighted number. And for a 15-minute exposure, that worker has a higher limit, but it's a very short period of time that we're not going to want the worker exposed to for a particular chemical. Those are the two most common. There's a third type that's also called a ceiling limit. That's much rarer. A lot of chemicals don't even have a published ceiling limit in the Washington Administrative Code. Those are levels though where that's an instantaneous limit as much as can be measured, and that is that you're just never allowed to have a worker that's exposed with outside of protection for that chemical. Lastly, here I've got our action level. So the action level is a slightly different category, but it's still very important. So each of these ones above are a type of permissible exposure limit. The action level is a level that is below the permissible exposure limit. Usually it's half of the permissible exposure limit for the time-weighted average. That's not true in all cases. For example, the common one that a lot of people might know about is that lead's number is 50 micrograms per cubic meter. It's not 25 as an action level, it's 30 is the action level. That's just a weird example, but most of the time it's half though. And action levels trigger additional monitoring and additional medical surveillance. So we might have a situation where we've got a number that's 50 for our permissible exposure, and we come back with samples that are 35. That would trigger that we need to repeat monitoring in some cases, and we need to have medical surveillance being done based off of the type of compound and what's present. That way, any future work that takes place in a slightly different condition that caused us to be 30% higher just due to slightly changing factors, that we're not accidentally exceeding that permissible exposure limit without realizing it. That keeps us in the safe ranges and making sure we're not getting our workers exposed to levels that we wouldn't want them to. Okay. So next, I will just talk through here the exposure assessments. So those are required under our Washington state standards. Those you can find in the Washington Administrative Code. You'll hear them referenced as both an exposure evaluation or an exposure assessment. You'll hear both those terms. So those are the same type of thing going on. When you are doing an exposure assessment, your goal is that you're demonstrating that you have a known hazard in an airborne situation that the worker is working in, and you are looking to demonstrate that you are below the permissible exposure limit based off all the engineering controls and environmental conditions and tasks that are being done. And it is, until we've demonstrated that, we want workers to be using appropriate PPE protection, such as respirators, when we are in any sort of situation where there's a lack of knowledge about the exact exposure that a task might be. The historical data usage is available when we have a well-known job type that again undergoes those same types of requirements, where we've got a consistent manner in which work is performed, we've got consistent environmental conditions, consistent scopes and durations, and the contaminants aren't changing. That's when historical data, when we have a well-established historical samples that have been collected, that's available to be used. So now for the Washington State exposure assessment expectations, we are looking to get representative breathing zone samples. Oh, go to the next slide here. The Representative breathing zone samples, again, that means that if we've got 10 workers performing exactly the same job, we don't need to sample every single one of them. We want to sample a representative subset of them. But one of the main important requirements is if there's any expectation or suspicion that one or two or three of the workers could be in a slightly higher concentration area, we need to make sure we have samples from what we would on-site guess is the worst case scenario. So if I've got 3 workers in a line and one of them is closest to the hazard, one of them is furthest from the hazard, we want to make sure we've sampled the worker that is the closest to the hazard when performing an assessment. The worst case scenario is the golden rule for that type of thing, is that always keeps us in good documentation and good lineup for it. Then lastly here, the documentation that we're keeping on site, that needs to be the whatever report or whatever historical documents sampling, those need to be present as we have a work site where there's known airborne hazard that is present and that is being used. Let's see. So now what happens? What are we going to do when we have limits that are exceeded for an exposure assessment? So first off, we are most important thing is that we stop and modify the work. We don't want to continue doing work when we know that there's a hazard and the hazard has not been addressed in any way for an airborne contaminant. First thing then we also want to do before we just go and order respirators for all our employees, by far the better thing to do is to get rid of the hazard in any ways that we can that don't require PPE specifically. So first things, and these can be slightly longer term things, they can be shorter term things, but we want to improve work practices, improve engineering controls, improve administrative controls. So whether that's the sorts of things like adding in local exhaust ventilation. So if I have a step of my work process that was just being done on an open table, I might move that to a fume hood. Or if I have an unshrouded vacuum that was being used, I might add a local exhaust shroud to my vacuum. I would move a type of work inside of polysheeted containment and get it so that it's not impacting anything outside of the immediate work zone. And only after those sorts of controls have been put in place are we going to then look to say, okay, we have all the reasonable changes we can make. We're still having air samples come back as above a permissible exposure limit. That's when you would long-term stick with a respirator program for your employees. And anytime you're in a situation where you don't know, there's a hazard present and you don't know the level of the hazard, that's when you should have respiratory protection in place until you've got all the information needed, what's the level. And then long-term, you would stay with the respiratory program if there has not been found a feasible way through engineering controls, through work practices, through admin, through just any way to eliminate the hazard itself. That's when you would stick with a worker respiratory program that goes with then all the medical evaluation that goes with respiratory programs and that sort of thing. Then lastly, if you have a exposure assessment where we have a consistent level of exceedance of either permissible exposure limits or of action levels, we do need to do remonitoring in order to verify that controls are effective and in order to keep showing that the levels are not increasing or that there's been no change. And so when there's an active hazard that's been long-term shown to threaten, that remonitoring will be done on periods of something like 3 months or 6 months, depending on what type of hazard you have, whether it's depending on whether it's crystalline silica or whether it's lead or asbestos, and then also depending on what action level or permissible exposure limit was exceeded. So those sorts of details, it's going to be different for each different situation. So your safety manager or officer will need to get the details for each situation as it comes up. And then lastly, we've got Washington, just as a general rule, is often going to have stricter rules than the federal limits. This isn't true in all states, but Washington itself, that's just a general rule, especially with regard to documentation. Washington has a lot of documentation rules for exposure assessments that are more stringent to make sure that you have things like medical surveillance done, things like documentation kept on site and an existing report or set of results that show what is the exposure of an employee to respirable crystalline silica, to If you work with methylene chloride on site, then same thing. If you're dealing with asbestos, same thing. So Washington DOSH is on the stricter end for that sort of thing. And then lastly, this is not the sort of thing anyone wants to encounter, but when Washington does encounter situations where rules have been worked around or they've been skipped over, that we will have the governing bodies, they'll issue work stoppages, they'll issue fines, and it'll cause delays. And whenever I've worked with companies that have had that happen, it's always, nobody's ever having a good time with those. And it's always going to be a situation where it would have been nicer for everyone involved to have gotten our stuff ducks in a row all along before a labor and industries inspector comes on site or any of that sort of thing. So I think I'll pass it back over to you, Omar, and finish out there.
Thank you. So basically, how do these assessments work together? The hazmat surveys tells us what's present before any construction work begins, and the exposure assessments tell us what the workers are breathing. Together, they're going to pretty much allow the projects to be planned properly and then executed properly. So hazmat surveys versus exposure assessments. Don't think of it as a versus, think about it as during and before. Like I said, the hazmat survey is going to be before the work. It's going to identify the materials, include sampling, and it's going to go into the planning phase for the contractors, and that'll lead to permitting afterwards. The exposure assessments are done during the work. They're going to measure the workers' exposure limits through air monitoring, and they're going to protect the workers in real time by seeing if they're being exposed to any hazardous materials in the workplace during the work. Some of the key takeaways of this presentation is plan before disturbing the materials. Make sure exposure assessments are documented and defensible. And remember that Washington state requirements are often stricter than federal rules. Starting early prevents injuries, violations, and cost delays. So that's all we have. So thank you everyone for your time. And if anyone has questions, let us know, or you could put it in the chat. But thank you for your time.
Yes, this was absolutely wonderful, and also a great deal to have multiple people speaking today on for NVL. Thank you so much for your expertise and professionalism. Folks, I would like you to shoot over any questions in the chat room that may have not been answered. You can also, oh, wonderful, I see some thank yous coming in there. I'm actually going to share a screen back on the main slide deck. Actually has contact information for Umer and his team at NVL Laboratories. There's a phone number. There's the website. You can get a hold of them. So if you want to screenshot this, that is fantastic. Is there any questions? This is open mic time. Is there any questions for the NVL team out there? I saw some, there was definitely some questions flying around, folks in the chat rooms, and people were shooting back and forth information and answering those questions. Was there anything that you have for Umer and the team? Well, we certainly appreciate it, and you no doubt will be contacted probably by more than half of these folks in the session. It's at some point in their career, if not more. I certainly know that we have utilized NVL for the 25 years that I've had in the industry, and you guys have always been outstanding resource, a wealth of knowledge, and we appreciate you taking time to. All right, folks. I don't see any questions coming down the chute, but I will go ahead and wrap this up, and I can also allow for open mic now if anybody. Oh, hand up, please. Yeah, I must have missed that. Go ahead, please.
Yeah, hey, Red, it's John. Hey, I put a question in the chat, but when they were going over the examples or the ceiling levels measurement, and I was just wondering if there's like a typical chemical or product or something like that that might actually, we might be using that ceiling level measuring. Thanks.
Are you talking about, this is Russell, are you talking about, does that only apply to one or one specific chemical, or are you talking about the ceiling measurement as like a category?
No, not as a category. I get it. It's just so that there's I think when the presentation was being talked about, said that there's a limited amount of like chemicals or something like that. I was just looking for something that we might be using within the construction industry that we would be doing a regular ceiling level type of measurement on.
Ceiling level is one of the less common ones. It's in, you can go look up the table. It's in there if you want the exact number. It's 296841, and then you go find the permissible exposure limits. It'll give you a big long list. As far as like a common one, I'm trying to think if there's anything that's pretty expected. Probably, I think carbon monoxide has a ceiling level. It also has the other ones though. So that one is, I think you'd be much more likely to encounter just the time weighted average 35 ppm for carbon monoxide. That one is the type of thing that's really extreme, where it's like 1500 ppm. As far as like asbestos and lead, there's not usually a ceiling level is for some of the more dangerous chemicals where you just don't want to ever have someone encounter it, or it's for a chemical that doesn't have a known exposure, but there's kind of a ceiling level is it's kind of a high number, but it's like, if you ever encounter this, that would be really strange, and we should just get rid of it. We don't want to have it that effectively present on job sites. So it's kind of in its own side category, but when you scroll down the list, you'll see 90% of stuff doesn't have a ceiling number.
Got it. Thank you.
Certainly. Any other questions?
I guess I'm going to ask